Welcome to DCL-701. This is going to be episode 1 in probably a 4-part series on specifically the NanoVNA-H4 family of products. So look for 702, 703, and 704 by, I would say, the 10th of July 2025. If you subscribe to my channel, you'll get an alert when I post the next video. In this video, I'm going to go over basic setup, how to get around the menus, and point out many menu items you can ignore for now. Now later on, when you do more sophisticated stuff, you're probably going to have to learn them. But a lot of the menus you see in there, you don't have to worry about and you don't have to touch them. We're going to do something very basic in this video. Learn how to calibrate the touch screen, clean up the display, enter a frequency range, calibrate the device, and scan or sweep our antenna or dummy load or whatever we want to test. Now I know that the thing can do a lot more than this, but we've got to start off small and slow if we're going to learn how this thing operates and how to use it, especially since there's no owner's manual. This is the exact instrument I have. I was kind of having a negative opinion of cheap test equipment until a friend asked me to evaluate his H4, and he mailed it to me. I was so impressed that in 24 hours I bought one of my own. I was then even more impressed when I compared it to the VNA in our R8200 at the lab. These two instruments in the 1 to 500 megahertz range sweep antennas and report almost the exact same readings. That absolutely floors me. I did not expect that much accuracy out of a $100 instrument. But all I can do is report what I'm experiencing. So I've gone from doubting at the cheap VNA to being a really big believer in it. I urge new people in ham radio or land mobile radio to give one of these instruments a chance. There is a learning curve, and my videos are here to try to address that. You won't learn everything from me. I have some other things to recommend at the end of these videos, actually the end of this video and the next one, that I'll tell you about other resources. But I think I can help you along here in the next half hour. So let's unpack this thing and only grab what we need out of the box. That would be the H4, this cable. I like to use the wand to navigate the menus. The charger cable, I keep mine plugged into my laptop all the time to keep the battery in the H4 up as good as I can. You need the calibration kit, and you need this double barrel connector, I call it. Step 1, put the double barrel connector on there and tighten these fittings with a wrench. You've got to make sure your fittings are always tight, otherwise the instrument will lie to you. This one, I don't have the guts to tighten with a wrench, but I make sure it stays tight. Now, I direct your attention to all these text sentences in the circle. What they're telling you is they're telling you what trace, and there's 4 colors, what trace is talking about what port. These are the ports. These ports are described as S11 and S21 in all of the menus. S parameters come out of the world of engineering. We test for S parameters. We don't have to talk about that right now. Just remind yourself when it says S11, it means the top port. When it says S21, it means the bottom port. That's all you have to know. Here's your calibration kit. There's your load. You and I would call it a dummy load, but they just call it a load. Here's a short. This shorts the cable or the line. This is an open. Now you might think, well, why don't I just leave the line open? You can't do that. When you're calibrating, the VNA has to see an open with no electrical interference whatsoever. So this open is really a shield. So you have a shielded open. Adapter kits. I like this one on Amazon. It has more than you ever need. It is a little pricey. This is a cheaper one that has only the common RF connectors. but even $138 is a lot of money. If necessary, go out and get some SMA male to UHF female or SMA male to N female adapters or whatever you need to connect the VNA to your feed lines, or I should say antenna cables. These are very cheap. You can get them 2 for $8 on Amazon. You can get almost anything 2 for $8 on Amazon if you search enough. But you're searching for SMA male to whatever connector you need. All right, let's take another look at the device. As I said before, memorize. See, this is port 1, this is port 2, but we always refer to them as S11 and S21. Through the charge port, you can not only just charge it, I can show you in a later video how you can use free software to gain remote access, to get screen data, and to even do a factory reset. As a matter of fact, I did a factory reset on it. That's why mine looks like it does. It looks like the day I pulled it out of the box, because I wanted to show you how to take it from factory configuration to a usable configuration. On-off switch at the top, and there's a rocker and push switch. This is used to vary the frequency of the display and to navigate the menus. Some documents call that rocker and push switch the leveler switch. I don't know why, but some books I've read about the VNA talk about that. If you push that button, you get the menus. If you roll that button to the left, the menu selection goes up. To the right, it goes down. If you roll it all the way up to the hidden one on top, it turns the menu off. If you turn the menu back on, there won't be anything highlighted because it'll be up here. You'll have to roll the switch to the right and bring this down. If you roll it down all the way down to this one to turn it off, when you bring the menu back up, resume sweep will be highlighted. All right, let's deal with the screen. As you can see, it's a mess when you pull the thing out of the box. So now you're going to get a lesson in how to clean that up and how to use menus. And for that, I made a video. Okay, to get started, we're going to turn it on. And as I said, the screen is a mess. Now, before we get going too far here, let's take a look at this cursor here. This is the yellow cursor. It's telling us that at this frequency, I have a return loss of 1.6 dB, which you'll find out later is really bad. On the Smith chart down here, it's telling me I'm seeing 6 ohms of resistance with a capacitive reactance of, it's hard to see, about 38 ohm. Which of course is wrong. All that is wrong because this instrument has not been calibrated. The return loss is 0. And that resistance measurement should be infinite because there's nothing terminating the cable. But again, it hasn't been calibrated yet, so it really doesn't know what it's looking at. Now, these are readings on this port here, S11. Over on S21, I have these 2 traces, but we're not using S21. So we don't care what these say, they're meaningless. Well, if they're meaningless, let's get rid of them. You want to invoke the menu. You can push the rocker switch. I like to use the touch screen. So you go to display. Now we're in the display menu. We want to look at traces. We have 4 traces. Notice by default the first one is lit up. We already know we want to get rid of this purple one and this light blue one because they're on the wrong port. So let's go to the light blue one, trace 1, select it, hit it again, and notice the checkbox goes away and the trace went away. Go to 3, select it, oops, select it, check it again, it unchecks, it goes away. So we've eliminated our 2 traces that we don't want to have right now. Now,
just in case yours isn't set up like mine is, let's verify, I'll show you how to verify what these traces do. We select it, we go back. Because it's selected, these three buttons are now going to adjust the yellow trace. It's assigned to S11, which is this port here. That's what we want. To format its function at S11, we go to Format S11. And you want log mag checked. That's return loss. Again, I'll explain why in a few minutes. If anything else is checked, just check it. Now, of course, if it already says S11 log mag, you didn't really have to go into this menu, but I wanted to show it to you. Now, we come back to the display menu. We go back to trace. Now let's select the green one. Back up. Now, we've already got, as I said before, it's already assigned to S11. Again, this port. Let's check the format, which we already know what it is. It's a Smith chart. It says Smith right here. This is the Smith chart selection. If yours doesn't say Smith, check this box. Then go back, and then go back again. And if the menu doesn't want to go away, just touch anywhere. Oh, that's not all the way back. There we go. Now we're at the main menu. You'll always know you're at the main menu when the bottom selection isn't the word back. So now we've cleaned the screen up.
All right, now moving on. It's time to use the thing, but we've kind of got to, I guess you could say, program it and then calibrate it. Yes, I have a video for that.
All right, here we go. We bring up the menu. Now, for whatever reason, the way they translated the instructions, to do a sweep or a scan, we set up a stimulus. And I guess we're stimulating the antenna or something, I don't know. We want to start, I'm going to start at 5 megahertz. Bring the menu back again. I'm going to stop at 10 megahertz. Now, if you look at the bottom, our start is 5, our stop is 10. So this is 5 megahertz, this is 10 megahertz. So I set up my scan. I can use this rocker switch and notice the cursor moves and the frequency changes. Let's bring it down to the 40 meter band. 7.1 megahertz, all right? Now, the Smith chart tells me I've got a mess here. Well, we haven't calibrated, so who knows what that really means. And besides, I haven't hooked my antenna to it yet. But the fact that I haven't hooked my antenna to it means this dot should be way over here. This point right here is an open. In other words, it sees nothing. This dot right here is a short. This intersection here is a perfect 50 ohms. So clearly this thing's not calibrated because it doesn't think it has a full short, or a full open, I'm sorry. So let's calibrate it. Anytime you change the frequency spread, you've got to calibrate. So what we do is we go to the, I didn't set this back the last time, see that? All right. So let's calibrate. We hit calibrate. We hit reset. Did that really reset?
No, of course it didn't, because the button only works if it turns dark blue. It didn't turn dark blue.
I guess it did. Okay. Now hit calibrate. Now the menu is going to guide you in what to do. It wants an open first. So take your little open adapter or termination, tighten it onto the end of the cable, hit open. Wait for the checkbox. Okay, now it wants a short. Take off your open, put the short on. Now come in here. All right, happy with that. Now let's give it a load. In other words, the 50 ohm dummy load. I'm going to hit load. Now we're going to hit done. If you want to save it, which I always do, press one of these. Now if you bring the menu back and go back, you can go to recall, and there it is, you saved it.
Okay, I don't think that was too painful, was it? Now, what I should probably point out, because calibration is very important, is that checking calibration can be done at any time, and it's super simple, and you don't even have to touch any buttons, provided you have the Smith chart displayed at the time. And I even have a video for that.
Anytime you want to check calibration, it's easy. Let's say I've got my little cable still on here, but there's no termination. It's not hooked to anything. I should see this cursor right here, and if I vary my frequency, it shouldn't move, and it doesn't. So let's put a let's put an actual open on there, because like I said, I had nothing on the end. Let's put our real open on, which shields us from any electrical interference. And you know it's going to pass because it did without a shield. Okay, so we're calibrated across the spectrum for an open. Let's put a short on there and see what we see. Exactly what we want to. It's showing dead short with no reactance. Using the rocker. Yep, that looks good. Take off the short. Now put your 50 ohm load on. Look at that. It says I'm right at 50 ohms, no reactance. If this was higher or lower, it would, well, high would be inductive reactance, low would be capacitive. This is perfectly 50 ohms. If I move my frequency around, it just sits there.
You'll notice I kept dragging the frequency back and forth with the lever switch. I'm absolutely convinced that that is unnecessary. Anytime you want to check calibration, put the open termination on, and you should see this. The Smith chart should be sitting right here at open, and your return loss should be at the reference line. Put the short on. The Smith chart should be at the short, and the return loss should be at the reference line. Put the dummy load on. The Smith chart should sit right at 50 ohms, right in the middle of the screen, and your return loss should be at max, essentially 80 dB. If you've got those conditions, you're calibrated just fine. Now it's time to actually use the device to do something with it. And yes, another video.
We're now ready to sweep my antenna. I'm going to hook it up here. I'm sorry you can't see me do this, but in order to get a good shot of the screen, you're going to have to trust that what I say I'm doing, I'm really doing. So I'm hooking my 40 meter inverted V up. All right.
Let me stop this right now. The reason I like to see you have the return loss and the Smith chart on the screen is it's presenting a lot of information to you. In the next two videos, I'll talk in depth about this number and this data here and this crazy squirrely loop-de-loop. So don't worry about understanding all that right now.
So what do we have here? If we wiggle our frequency around, we find out right away the greatest return loss is 31 dB, which is wonderful. It's at 7.1 megahertz, so I've got a very good 40 meter antenna. Notice my response is very close to 50 ohms non-reactive. In fact, it's 50, almost 53 ohms, and there's like a fraction of an ohm of reactance, but it's pretty darn good. Now, if I move my frequency up, as you can see, the return loss is getting lower, which means the antenna isn't working as good. Because
I really shouldn't say the antenna isn't working as good. The proper term is the match isn't as good as it was at 7.1 megahertz.
It's not really representing that great of a load. Look, 66 ohms and considerable inductive reactance. If we go down in frequency, the same thing happens, but now I have capacitive reactance and even lower so-called resistance. Okay. Now, some of you are probably asking, that's fine, I want to see SWR. Then let's give you SWR. Well, I didn't put it back where it belongs, did I? All right. So we want to go to display. We want to assign a trace to SWR. I like purple. Let's grab purple for SWR. Let's go back. We want to set our purple trace to this port. Okay, now it's on S11. We want to set it for SWR, which is right there. Now we're going to back up, tap out. Now, SWR, and I know it's kind of hard to read, SWR is 1.067 to 1 at 7.1 megahertz. And if we go up a little bit, let's go to 7.3, top of the band. At the top of the band at 7.3, I've got 68 ohms of resistance with quite a bit of inductive reactance. I've got an SWR of, goodness, over 2 to 1.
And again, the reason I misread the Smith chart numbers is the jig I used to hold the camera and the phone made it very hard for me to read what was on the screen.
What happens if we go to the bottom of the band? 7 megahertz. Well, I'm not too far from 50 ohms, but now, look at this. I'm below the line, so I'm capacitively reactive. My SWR is 1.4 something to 1. That's not too bad. But do you see what I mean? If we didn't have the return loss, SWR doesn't really tell us that much about the antenna. Return loss gives us a much more fine readout of what the reflected power is, but the Smith chart is telling us exactly what we're seeing. Now, some of you are probably asking yourself, okay, he went higher.
Okay, I'm going to stop this right here because at this point I get way off into the weeds and I did not mean to do that. So let's move on. I've got 2 items for you. Number 1, buy this book if you can find it. I think it's still on Amazon, and I think DX Engineering still has a few copies left. Maybe HRO has a few. It's a little dated. It'll tell you that the accessory cables and the firmware have problems. Well, that was years ago. Those problems have been fixed. This is the closest to an owner's manual I have been able to find. The other item I wanted to talk about was that next time my video will concentrate on the terminology and the theory behind the Smith chart, return loss, reflected power, and SWR. Those 4 items, if once you understand them, the display on the H4 makes a lot more sense. It's not really that complicated. I believe I can explain it in a way in a few minutes where you can sit back and say, oh, this isn't that hard. It looks weird on the screen of the NanoVNA, but it's actually, a lot of these concepts aren't that hard to understand. They've just got to be explained slowly and with like demo data, okay? I hope this has been worth 25 minutes of your time. The next video will probably be just about as long. I like to keep them under 15 minutes, but I just can't do it with this topic. I encourage you to play with your VNA if you already have one. I will try in the next video or two to show you how to do the factory reset so that you can start over anytime you want to. Anyway, have fun, and I hope to post the next video before the end of the July 4th weekend, 2025.